Hi, this is Mr. Shumway. This video clip explains what a function is. Well, we've been doing equations, things like y equals 3 times x plus 4. Y is going at 3 times what x is and starting at 4 when x is 0. Well, the function is just written a little bit different. You might say a function of x is 3 times x plus 4. So it's really not much different than the equations that we've been using. One thing we need to explain though is domain. Domain would be the values for x. So integer values would be numbers like 1, 2, 3. So if I have this equation, y equals 3x minus 2, let me write it as a function. The function of x equals 3 times x minus 2. So using 1, when x is 1, y is 3 times that minus 2. 3 times 1 is 3 minus 2 is 1. So we have the point 1 comma 1. When x is 1, y is 1. When x is 2, 3 times 2 is 6, minus 2 is 4. So when x is 2, y is 4. So for integer values, we will have points on a graph. If x is 0, 3 times 0 is 0, minus 2 is negative 2. You knew that already because you know that that's the y-intercept. But what about numbers in between? Can you have a rational number like 1/2 is written as a ratio? Okay, so let's say we go we put it into our function, a function of 1/2. That will be 3 times 1/2. Let's write a little neater. Function of 1/2 is equal to 3 times 1/2 minus 2. So that is 3/2 minus 2. That's 1/2 minus 2. So that's minus 1/2. So if I go x is 1/2, y is negative 1/2. So it's that point right there. You can see that, well, you might be able to see that that's on the line. Anyways, another rational number might be, let's do 1/2. Let's do 3/2. That's a rational number. So the function of 3/2 is equal to 3 times 3/2 minus 2. So that would be 9/2. 3 times 3 is 9. 9/2 minus 2. Well, 2 is 4/2. So that would be 9/2 minus 4/2 equals 5/2. 5/2 is 2.5. So if x is 1.5, y is 2.5. So I'll go over 1.5 and up 2.5. Hope you can tell that that point is also on the line that goes in between the points that we already had from the integers, but now we're using rational numbers. So the domain, you can choose whether you're going to use integers or if you're going to use all numbers. And one way to indicate that you're going to use all numbers is you could say all rational numbers. So that includes any fraction. I just showed a couple simple ones there. Oh, another thing I ought to point out is that what we call end behavior. Meaning, we're just looking at a small piece of the graph. This arrow shows that we keep going. So this line keeps going. So if we continued on as x approaches infinity, this line would keep going up and up and up towards infinity. So we say that as x approaches infinity, y also approaches infinity, or the function of x approaches infinity also. We don't draw the whole thing, but just we don't draw the whole thing, but we can say what that line would do if it continued on. That's what we call the end behavior.